And if I can only run one block on that SM, then I'm getting a maximum of 1,024 threads on that SM. So my occupancy is not as high as the SM could handle. You can get these vital statistics for the particular GPU you're programming to by looking it up in the CUDA reference manual or by making various CUDA calls on the GPU. And the CUDA SDK ships with a sample called device query, we saw it earlier, that conveniently collects all of this information into a single useful utility. So earlier we did a printout of the device query, the result of device query on my GPU. Let's look at that again. It prints out a lot of information. Earlier we were using this to estimate the total peak bandwidth by looking at the memory clock rate and the memory bus width. Now I want to draw your attention to the total amount of shared memory per block, the total number of registers per block, the maximum number of threads per multiprocessor, or SM, the maximum number of threads per block. And here's the register and shared memory usage for our tiled transpose kernel. Going back into NVPP, we can see that we're launching a grid size of 32 by 32, a block size of 32 by 32. We're using 7 registers per thread, and we're requesting 4 kilobytes of shared memory per block. So given the register and shared memory usage for the kernel that we just saw, and given the GPU statistics from device query running on my laptop that we just saw, how many thread blocks per SM can we run? And how many threads per SM can we run? And which resources are preventing us from running more? Are we limited by the maximum number of threads per SM? By the maximum number of registers per SM? By the maximum amount of shared memory per SM? Or by the maximum number of thread blocks per SM?